Kary Mullis is a famous researcher, most known for his invention of the polymerase chain reaction, otherwise known as PCR, for which he won a Nobel Prize in Chemistry in 1993. Today we're going to be talking about how this reaction works. There are 5 main components of PCR. We have the buffer, which maintains a stable environment for the reaction to occur, template DNA, a DNA polymerase enzyme, 2 primers, and DNTPs, which includes adenine, cytosine, guanine, and thymine. The first step of PCR is denaturation. This is the hottest step, done around 95 degrees Celsius, as we denature double-stranded DNA into single strands by breaking the hydrogen bonds as seen. The second step of PCR is annealing. The temperature of this step depends on the type of primer used. In this step, our DNA primers will now attach to complementary DNA sequences at the 3 ends and will flank our gene of interest. In nature, RNA primers are used. However, DNA primers work fine in PCR. The last step is extension, and this temperature varies on type of DNA polymerase used. Here's where the DNA polymerase comes in and attaches to primers and starts to extend the DNA strand by adding the complementary DNTPs in the reaction. It is important to note that you need to use a thermostable DNA polymerase, such as Taq polymerase, which was discovered by Kary and Mullis, in order to do its reaction, as otherwise the DNA polymerase will have to be replaced in every cycle. The process repeats over and over, and every step doubles the DNA content in the reaction, as seen here where we start with 2 strands and now have 4. This allows scientists to make millions of copies from just 1 strand. It is clear to see how PCR is very useful in many fields of science. It put Kary Mullis on the timeline of scientific discovery, and his name will forever go down for his invention of the polymerase chain reaction. Thank you for listening.